So in this question, we were supposed to solve the specified conditions, but then from the Laplace transform formulas, we solve initial value problems when the independent variable conditions are picked from 0. But now in this case, we have been given y at 1 and y prime at 1. So the first thing that we do is to transform these conditions so that we start from 0 instead of 1. So let's demonstrate how to work out this. So our question is to solve now the problem should be transformed so that this value here is 0 and then this value here is also 0. So we'll say let a new variable u be given by t minus 1. We are picking this new variable t minus 1 so that when we put the value of t to be 1, then u will be 0. And so we'll have the correct form of the initial conditions. So which is the same thing as saying t is the same as u plus 1. Now, this means du is the same as dt. And so this differential equation can be written as d squared y dt squared, because it's in terms of variable t, plus 2 dy dt plus y equals to t. Now, remember this is the same thing as saying du dt is the same as 1. Now, dy dt, so we want to transform our differential equation from the independent variable t to the new independent variable u. So we need to express everything in terms of this new variable u. So we'll have dy dt by chain rule is given by dy du and then times du dt. And you see this is the same as dy du, but the value of du dt from this one is 1. So yes, same as dy du. Similarly, let's also express the second derivative in terms of u. So d squared y dt squared means d dt of dy dt, which is the same as d dt. From this, we have found dy dt the same as dy du. Now, in this case, if we have this kind of operators, we can always switch dt and du so that you'll have d, then put the u outside and then bring in dt, so dy dt, which is the same as d du, dy dt is the same as dy du, and this will give us d squared y du squared. So therefore, replace into the differential equation these new derivatives in terms of u, and therefore our differential equation becomes, if we call this one this star, then we say star becomes, with these values, star becomes d squared y du squared, and then plus 2 dy du and then plus y equals to the value of t the same as u plus 1, subject to the condition y. Now remember, this is now purely in terms of u. So when t is 1, putting 1 here, value of u will be 0. So it will be y of 0 to be 0, and also y prime of 0 to be 0. Now so this now be the equation that we are going to be solving with this given condition. Let the inverse Laplace transform of y be given by capital Y of S. And we know that the inverse, the Laplace transform of dy du will be given by S y of S, and then minus y at 0, which is the same as just S y of S, and the Laplace transform of the second derivative of this function from definition is S squared y of S minus S y at 0 minus y prime at 0. And replacing these values for 0 and 0, we just get this one as S squared y of S. So supplying, if I call this one equation 1, finding or taking Laplace transform on both sides of 1, we get the Laplace transform of d squared y du squared plus twice Laplace transform of dy du plus Laplace transform of y is the same as Laplace transform of u plus Laplace transform of 1. So with the values we have, this will be S squared capital Y of S plus 2S capital Y of S plus this one is capital Y of S, should be given by, now Laplace transform of u is 1 over S squared, and then plus Laplace transform of 1 is 1 over S. So factoring out capital Y, we'll have S squared plus 2S plus 1 capital Y of S equals to, actually I can put this over same LCM S squared, and then you can have 1 plus S. And remember, if you factorize this quadratic expression, product here is 1, sum is 2, numbers will be 1 and 1. So we'll have S squared plus S plus S plus 1. So first term S is common, first two terms S is common, so S plus 1 plus 1 is common in this second last two terms. So which will be S plus 1 times another S plus 1, or simply S plus 1 squared. So this would be written as S plus 1 times S plus 1 capital Y of S equals to, this can be written as S plus 1 divided by S squared. Now, to be able to get the value of capital Y of S, we divide S plus 1, S plus 1, and then S plus 1, S plus 1. So that on the left-hand side, this cancels out. So we have y of s equals to, now this and this cancels out, so that we have 1 over s squared into s plus 1. So then we need now to get the partial fractions of this new rational function. Now 1 over s squared into s plus 1 is a over s plus b over s squared plus c over s plus 1. These are correct partial fractions expressions for this given rational expression or function. So which is the same as s squared into s plus 1. S into this will have s plus 1 times a, plus s squared into this will have b into s plus 1, and then plus this into this LCM will have c times s squared. Now, this means that 1 is equals to as into s plus 1 plus b into s plus 1 plus c s squared, which will give us, when s is -1, then we'll have 1 equals to, so we'll not have this term and this other term, so we'll have c into -1 squared, which implies 1 equals to c. And then when s equals to 0, we'll have 1 equals to b into 0 plus 1, which means b is also 1. Now, if we take s to be 1, then we'll have 1 equals to a into 1 plus 1 is 2, plus b into 1 plus 1 is 2, plus 1 squared is 1, so c. So which will be 2a plus 2b plus c. But we have known that c is 1 and b is 1, so this means 1 equals to 2a plus 2 times 1 plus 1, which means 1 equals to 2a plus 2 plus 1. So which means 2a is minus 2, because this will be 3, 1 minus 3 is minus 2. So which means that a is -1. So therefore, capital Y of s is -1 over s plus 1 over s squared plus 1 over s plus 1. Now, if I call this one equation 2, taking Laplace transform on both sides of 2, we get that actually inverse Laplace transform, so that now we get y of u. Inverse Laplace transform of y of s, it is same as inverse Laplace transform of, actually I can say negative and then 1 over s plus inverse of 1 over s squared plus inverse of 1 over s plus 1. And all these are standard transforms. The inverse Laplace transform of 1 over s is 1. So this will give us 1 minus 1 plus the inverse Laplace transform of 1 over s squared will just give us u, because the variable of y is, so this function y in terms of u, and this other one will be plus e raised to power negative u. But we know that u is given by t minus 1, which means the function y of t will be given by negative 1 plus t minus 1, and then plus e raised to power negative t minus 1. So y of t, now minus 1 will be minus 2, and then this will be positive, so we'll have t minus 2, and then plus e raised to power, this now 1 will be positive and t will be minus. So therefore, this is the correct solution to that given problem. So note that the method of Laplace transform can help you to solve the differential equation when the value of the independent variable in the initial conditions is starting at 0. So when the value is not starting at 0, you have to get the correct transformation that will guarantee that condition for you to be able to proceed. Thank you.